Okay, well, good afternoon and welcome everybody. And I'm sure you just caught there that my camera has decided to not function. So apologies for that. So for those who don't know me, I'm Jayne Bryce. I'm Director of CPD and BSHAA Board. And we're delighted to be joined by Tony Murphy, Wireless Communication Specialist at PhoneApp, who'll be guiding us through today's session. Remote microphone technology has been around for a long time, but many clinicians would agree that it's still underused, even though many of our clients would benefit significantly from it. Often that's because clinicians maybe feel unsure about the setup, or sometimes it's hesitation about introducing additional technology at a cost on top of the hearing aids. So Tony is here, he's the wireless communication specialist at PhoneApp, and he's got extensive experience supporting hearing care professionals in understanding and implementing wireless technologies that enhance hearing aid performance. So over to you, Tony.
Okay. Well, hopefully everyone can hear me there okay. Sounds as though there's a bit of an echo. I don't know whether someone's still got their mic on mute or hasn't muted. Is that okay? So what I'm going to do is really go through in a generic manner, relating to all hearing aid manufacturers, to be honest with you. Some of the different options, we'll go through a bit of a list here for you as well. So we're really going to take a step backwards for the first part and look at what they want to do, what they want to achieve. And, essentially hearing aid technology in some ways has the same limitations it's had for a long time. And the really interesting bit, and probably the more confusing, troublesome bit in many ways, is the wireless technology that, you need to use on it. I'll try to give you a brief history of the evolution of various different technologies as well. Obviously, it's a very complex, tangled web, but it's nice to review that. I think it's important also to review what technologies are currently used. I'll look at, again, the benefits and limitations, because no technology is perfect. And very stupidly, I'm going to try and predict some of the things that may or may not be happening in the future, which obviously is a bit of a changing path, but I'm sure there's a lot of things that you may need a little bit of clarification on, or hopefully have many questions on that. On the point of questions, I think we'll probably leave them to the end if that's okay, and then we can discuss them in a little bit more detail rather than jumping in and jumping out. So to make a start, the design. Now, I think everyone knows, not teaching grandmother to suck eggs with this one, but obviously a sound drops off or deteriorates inverse squarely with distance, or from a speaker, shall we say. But as a lot of things in physics, microphones are almost work the other way around. So you're using that sound to try and pick up, that microphone to try and pick up a sound, possibly from quite a large distance away. But the same rules applies. And the problem is, obviously, with hearing aid technology, the size of the microphone being, I don't know, 1, maybe 2 millimeters tops of a side, it's very difficult to pick up sound at greater distances. And obviously, if you're in a poor acoustic environment, really the issue is there's still all that information physically arriving at that hearing aid microphone, but because of the size of the diaphragm and other kind of limitations, it's just receiving all the sounds. So what we have to do with a hearing aid is try and differentiate the sounds you want to hear, which is usually speech, possibly music in some ways, and take that out of the encompassing background noise. So obviously poor acoustics will make this worse. And the only real solution at the moment, to be fair, is to take that microphone, if you like, and put it close to that person who's trying to speak to you. Yes, there's lots of other technologies in there, which I'll touch on today, which has made that a lot easier. But even with the advent of AI and all the wonderful things that modern hearing aids can do, your critical listening distance is just essentially governed by the physics. It's 2 meters maximum. In a poor environment, you're going to need some form of additional technology to help with that. I'll talk a little bit about Bluetooth and some of the other things as well. But again, for the physical microphone side of things, you're obviously still limited by the critical distance, which essentially hasn't changed, for a very long time. And unless someone can invent a wonderful microphone that can pick sound up at a further distance, then I think wireless technology in some format is going to be around for a long time to come. Okay. So the other thing that I think is really interesting, and I've worked for Phonak for what, I don't know, 23-4 years now or something, which is quite frightening. But even when I first joined, essentially hearing aid, the wireless technology was almost a secondary thing. And now I think it's not necessarily a marketing. I think it is a statement of fact. Your hearing aid is now more a communication tool. And the analogy what I would have is that it's really like your phone. Technology tends to converge. We still call our phones smartphones or mobile phones, whatever they happen to may be. And essentially, how often or how many hours do you use your phone to actually ring people up? And I was just thinking the other day, it's quite strange when I first started at Phonak. Obviously, we all get company phones for various different reasons, and you just spend all day on the phone talking to people, answering problems, questions, and those kind of things. And I think today I've had one phone call, which is quite amazing. We call them phones, but most of our communication is using other media, things like WhatsApp, emails, and all those kind of things. And I think, to me, that one of the huge benefits in terms of being inclusive in the environment or in the modern world today, certainly the wireless technology has played a massive role in that. But this is a particular quote I like, because my dad was a classicist, and he liked Plato and all those kind of things. There's a saying that he created, essentially, that any technology can be there for all good or bad. It's the human being that decides how to use it. And he was challenging one of his students, and that the preface was that should writing be banned because it's too manipulative. And that, to me, that's quite a staggeringly interesting thing. It's, we talk about AI now, it's going to take over the world and nobody's going to have a job anymore and all these weird and wonderful things. But it's the same kind of concept, isn't it? And again, I think for hearing aid technology particularly, it has made the fitting more complex, and that's something I'll touch on the back, on some of the later slides. Some of the things I think personally, we should be looking at as a company. And technology for technology's sake is not particularly good. You've got to look at what you're giving that person, because at the end of the day, all this kit is attached to a human being, whether it be an adult or a child or anyone in those kind of environments. It's quite interesting. I do work. My desk at work is very close to the tech support desk, and I think the vast majority of the questions that they are asked are probably to perform with some form of connectivity or not connecting to a phone or Bluetooth and those kind of weird and wonderful things. It may be a perceptional thing, but I strongly suspect that's taking up quite a lot of your time and probably a lot of tech support's time as well. So it's a very complex scenario. The technology, I would say, within a hearing aid now, and I'm talking in generic terms, is probably some of the most sophisticated technology that exists in any industry. I mean, a lot of people use earbuds and all those kind of things. People are just walking down the street chatting away. And that is, little earbuds, wonderful though they are, is they're only really working in a sort of basic Bluetooth format. Some of them nowadays, in fairness, can have almost sort of mild moderate hearing type of things, and all these kind of sort of hybrid systems are becoming a lot more popular. But if you think how long a hearing aid can stream music for, and all the weird and wonderful things that can do, and by the way, it has to work as a hearing aid, and you do noise cancellation, all those kind of things, and the size of it running off a very small little battery, you would expect nowadays that these systems should really, last a full day's work. I mean, my wife wears hearing aids as well, and she used to do a little sort of cleaning job in her retirement for a while. She would, get up 6:30, do that, listen to audio books all day, come home, and really the hearing aids would be still going at sort of 10, 11 o'clock at night. And it's quite staggering. If you stream music from your phone for those kind of hours or use an earpod, they just wouldn't work. So there's some really, really amazing technology within there. However, I think we're all guilty of it, all hearing aid companies. And we can get very obsessed with numbers, and it's a scientific company, they're all medical devices, so everything has to be sort of peer reviewed and all that kind of thing. But at the same time, just because you've got a faster processor or you've got some widget on there, new marketing terminology, how does that benefit the user? Yeah? And there's a lot of different sides to that, and there's quite an interesting lecture we were getting on sort of new products and all the rest of it from someone in our company, and they were talking about, I'm sure other companies do this as well, but obviously we get a lot of feedback from hearing aids, data logging, questionnaires, all these kind of things. All companies have to do it, because they're medical devices and it's all got to be proven. But they would say that when quite often if you ask a user what would you want, and they say, oh, maybe want better sound quality, they're not necessarily referring to the bandwidth of the audio signal or the output of the processor. I think what they really need or want or desire, shall we say, from any kind of hearing technology is consistency of use. You could have the fastest processor in the world, but if it only lasted, 2 hours on the battery consumption, that would be generally quite annoying. And also, particularly when you're listening to wireless technologies, you should be really just to get on the train, down, switch your Spotify on, coming from Manchester to London or something like that, and you don't want it cutting in and cutting out, and like having a phone call on a train, those kind of things. And the other side, of course, is hearing aids. Well, two things that all hearing aid manufacturers do is obviously the hearing aid microphones and the receiver at the other end, and essentially because of the physics limitations of those, a hearing aid may have some response up to about 8-10K or something like that, but how much of that is actually usable is debatable. So the other side of the thing is, we'll touch on this when we come on to the Bluetooth side of things, Auracast and that kind of thing, but does necessarily a 40 kilohertz bandwidth going, or 24 kilohertz bandwidth going into hearing aid necessarily give that person a greater clarity of the music? Because guess what, the output is going to be limited by the hearing aid. So I'll touch on that a little bit later on, because there is some important implications on that as well. Go over there. So if you look at the evolution of kind of hearing aid technology, and ultimately, as I said before, there's a person at the other end, and satisfaction of that hearing aid technology is essentially that you're achieving the expectations of what that person wants to hear. It's obviously a very complex topic. All manufacturers now use AI technology, and it's certainly fantastic. But that in itself could be challenging for that person. Human beings are very complex creatures. Everybody hears sound, or perceived sound, should I say, in a completely different manner. And yes, AI is fantastic, but do you necessarily want it all the time? So that adds the question, well, would you work it manually, or would you want it automatically, or you want a difference between the two? So that in itself is something perhaps reviewed in another kind of lecture. I would say also, obviously, any manufacturer, believe it or not, who's writing an article about their own products is probably not going to say they're very bad. So in my opinion, I think all of these features, again, we are a medical device company, so we can't basically lie like you can in other companies in marketing terminology. But I do think you need to look at peer-reviewed evidence, and evaluate this yourselves and make your own independent decisions on whether this technology is appropriate to what it says. You do get a lot of studies that are done, in very controlled conditions and all those kind of things. So it's important to do your background research and make your mind up about that. I think the other side of the coin is as well, and we had an interesting experience with this, trying to get a camera to work on Teams. You can have the most fantastic technology in the world, but how do you use it? You've got to scroll through 40 different memories buried somewhere in the depths of the PC or phone to get your camera to work when you're on a Teams, or when it's on a Thursday or Friday afternoon. It's not the best technology to use, is it? You want something just to kind of switch it on and work. And I think, without being biased, I think Apple are very good at that. Microsoft, infinitely clever people than I am worked there. But there was a classic example this morning. The camera wouldn't work. Why wouldn't it work? In fairness, the camera might be broken, but I strongly suspect there is a menu somewhere down there in the screens that can actually start with that. And the other side of the coin is, not everybody necessarily is great with technology. I don't mean that in a derogatory sense, but yeah, take my dad for instance. He was a classicist. He was absolutely hopeless with technology, and I tried to give him all sorts of accessories and things when he was alive, when he had hearing aids, and he just couldn't cope with them. And it wasn't because he was stupid. It's just his brain was a more sort of classic language type scenario. So you're making hearing aids for an incredibly diverse range of people. Right from babies right up to sort of people in the 90s, 100 or whatever. So that in itself is obviously quite challenging for all hearing aid manufacturers. But I do think, again, I'll look into that a little bit more detail later on. But it's quite a staggering array of people that we actually manufacture technology for. Okay, so this is one of my favorite words, and this is hugely important, interoperability. And as hearing aids have become more advanced, as new technologies have been used, how on earth do you get these hearing aids to work with all the different devices that are now coming onto the planet? And this isn't an overestimation, but on average, there's over 1 billion new Bluetooth devices launched onto the planet per year. And that will only increase as they find out more weird and wonderful things to actually do with it. And this is where you sometimes can get problems. I'm sure everybody's experienced it. You get a new phone and all of a sudden it's not working with your hearing aids. Now, the way Bluetooth kind of works, that is generally controlled by the phone, as the master, they call it. And the receiver just reacts really to what the phone says. So all manufacturers have to do it. An update comes on, say, Apple or whatever, and all of a sudden the app doesn't work or it doesn't turn off or behave in the same way. And then we have to go away and do an update. But the fantastic thing about software is we can do that, and we're even looking at updates through phones now, so you don't maybe have to use Target all the time to do this. And so the consumer rightly wants this stuff to just work. And I certainly think one of the most frustrating things when things just don't work and you can't figure out actually why they happen. So interoperability is related to a lots of different things, and certainly standardization is the key to that. Now, possibly most of you have heard of Bluetooth SIG, the sort of independent company that work on a lot of the standards for Bluetooth. However, to actually create those standards themselves, it's not necessarily SIG. There's lots of other technical committees and technical authorities that work on those standards years and years before you will actually see them coming into the marketplace. And then maybe they will be implemented in, say, Bluetooth Classic or Acast, or I'll talk about that in more detail later on. And so the concept is, if you follow that certain standard, and if the other manufacturers, say the laptop or the headset or the printer, follow those standards as well, when you try to connect to that technology, it should work. It should be seamless most of the time. However, for various different reasons, quite often the case is that a manufacturer, and I'll touch on this in more detail, there could be technical reasons, regulatory reasons, size, market reasons, or whatever. And this isn't just in the hearing aid world. They may change that standard, shall we say, a little bit to suit their own products. You certainly get that sometimes, not so much now, perhaps, with, say, Bluetooth enabled landline phones, those kind of things you use in call centers. A lot of them Bluetooth, a lot of them are wired, but you should theoretically be able to just connect your hearing aids direct to that Bluetooth landline phone system. But because they wanted you to buy their own accessories, they encrypted it so it would only work with certain devices. And that's just kind of how things work in the real world. But certainly I would say things like Bluetooth Classic, which I'll go over in more detail later on, the reason that kind of works so well now, and it is probably the most universally acceptable product. As I mentioned before, over 1 billion devices compatible with it per year. It is a mature standard. Nothing is ever perfect when it comes out. But if two manufacturers and all manufacturers adopting a Bluetooth system use the same standard, there's a great likelihood of that working better. And the interoperability relates to that. Everyone should be using exactly the same standards, and also it probably will create more consistent use. If say the phone is not working quite the way as your earbuds or whatever, that's kind of when you get dropouts and those kind of things. And of course, it's not the law. Bluetooth is not a medical device. You can get an awful lot of stuff that you can just see on eBay or the internet or Amazon and all these kind of things. Technically, yes, they've got Bluetooth, but guess what? They don't work. And that may be because some company somewhere in the world has just created this little Bluetooth device which may work in some circumstances, or it just doesn't for whatever reasons. And certainly because it's not to the same standard would probably be the case in most situations. So we go on to so there's no such thing as the ideal technology, and I think to me it's very much like your phone. And I think I'll probably mention this later on, but I'll mention it now because I will skip over slides. Your phone has essentially around, I don't know, it's probably a bit more than this now, but the last time I was told, you're probably about 30 odd different receivers and transmitters in the average smartphone nowadays. You think, what on earth would you want that for? And it's because of all the things that it has to do. You've got all your different Bluetooths, Oracast now in some form, but we'll touch on that later. And it's interesting as well, things like 3G, 4G, 5G, those kind of things. And you would think they're just like three technologies all working on the same frequency, but they're actually not. To maintain battery life on the phone and for the transmission, generally you can have all these technologies on multiple different frequencies. So say if you got off the train in London and you got on the train in Manchester, even though technically you will still have a little 5G signal on the top of your phone, you won't be listening on the same frequency. But the phone knows this and just switches to those technologies. Interesting as well, I mean, the whole race is to go higher and higher frequencies. 5G is a higher frequency than 4G was, and there's even 6G now as well. But the other slight issue is, yes, higher frequencies can ship more data, but they also need more power from the transmitters to send that signal. And because it's a higher frequency, that energy drops off a lot quicker. So if you were, say, in the city of London, there's 5G masts all over the place. You're in the middle of Yorkshire, there isn't, because it's not, economically viable for the companies to put these systems up. So it's quite a complicated scenario. So you could actually have the little 5G icon there, but it may be no faster than it is on 4G. But as long as it works for the user, that's fine. That's kind of how these things work. And really, that's how any technology should work. I mean, it's incredible. I always say in lectures, think of how many times you've used your phone during the day. You get up in the morning, maybe check the news out, so you're going on your Wi-Fi, you get into your car using another system there as well, you get into the office, you keep using other different things, you take phone calls, you send Bluetooth transmissions, you tether it to your phone because you can't get it to your laptop because you can't get a decent signal on the phone or a Houston station or something like that. So it's incredible how many times these are used, and this is really good technology. You shouldn't have to get off the train in London and say, I tell you what, I'm going to use 175.6 megahertz for my phone signal today. It just works. And, to be blunt, nobody even knows what you are using at any one time. Okay. So I'll go through some of the technologies as well. I mean, there's lots of different versions. Most of the sort of wireless technologies now use kind of Bluetooth things or variants of that. I'll talk very briefly. They use a band, the 2.4 gig band, 2.4 gigahertz band, with which Bluetooth belongs to, which Roger belongs to, and some of the other technologies as well. Streamers and phones and connectivities, and it's quite interesting. Telecoil, is still in existence, and I've got a slide on that later. And certainly things like the streamers for TV use, basic microphones, and those kind of things are great technologies, and obviously affordable for the people who work in quiet environments or in the car or something like that. So there's loads of different stuff. I'll briefly touch on Wi-Fi, and not really using a lot now, but there's some optical type systems out there as well. So as I mentioned before, Bluetooth Classic, and what I mean by that is sort of the original Bluetooth. That there's loads and loads of different protocols within that. So these are things like the hands-free protocol you would use in your car. It's optimized for the acoustics in your car and that kind of thing. Very clever. Things like the A2DP, which again is a classic example. I mean, if you are listening to a high quality track on that, you can have a 20 kilohertz bandwidth on that. So if you're listening with some great headphones and you happen to be under 30, so you can actually hear it in the first place. You can have stereo tracks. It's pretty incredible, and particularly when you play them on these little Bluetooth speakers. But the kind of history is that yes, this is amazing technology, but because it's sending so much data and it's quite an old technology, it's very power hungry. So there was a number of different things that we looked at as generic companies, I think at HEMA and all those kind of things as well. And the decision was made to try and, if you like, get the quality of signal of Bluetooth Classic and be less power hungry. And that's what you're really seeing, what they call as Bluetooth low energy audio. I think that came out about 10 years ago or something like that now. Again, it is very instrumental. It was really based from Apple, what they wanted to do. And so you said the MFI made for iPhone, and the Asher audios as well, and some of the other things going on there as well. I still think, Bluetooth Classic though is still the most universally accepted technology. It's not to say that low energy audio is a bad technology. It's just by its nature a bit more niche and not able to connect to as many devices. And Auracast, which is coming out, well, it's out now. It's been out for quite a while. That's kind of taking that a little bit further. The problem with Bluetooth in the unicast, as it's called, or the low energy audio technology, it was really a one-to-one relationship. Now, hearing aid manufacturers, being very clever, they've managed to sort of tweak that so you can hear in both ears. In some circumstances, you can even hear stereo and those kind of things. But essentially, Bluetooth Classic is a one-to-one kind of relationship. Now, unicast can go to a few different versions depending on what it was, but I think Auracast is really the next big step, and that allows one transmitter to broadcast to multiple receivers, okay, which in itself will be fantastic, but there's still limitations on what it can and cannot do and what you're trying to look at the moment. These things may be sorted in the future, but I can see all of these technologies being around for quite some time to be blunt. And that's just me saying it. Bluetooth SIG, they say that, HEMA, and certainly a lot of other manufacturers as well. Interestingly, telecoil, though, I usually ask people to guess this, but you probably won't know anyway. So it's quite staggering that this was first invented, I believe, in about 1928. It was used in the military, used for hearing aids as well, communication on planes and all those kind of things. And just by the nature of how many millions and millions of installations of telecoil there are, from post office counters to lifts to theatres, it's going to be around a long time to come. And I first was thinking probably about the last 10 years. And again, we had a lecture on some new products that come in from us in the future, as always. I'm one of the guys there in R&D, so maybe around for 20 years. And it's not because it's a particularly great technology. It's very simple to use, obviously. but it is prone to interference, and you know, it takes space in the hearing aids that, to be honest, could be used for other things. And I'm kind of hope in the future Oracast or a version of it could hopefully replace telecoil, because you don't need anything else apart from obviously a telecoil inside your hearing aid. But for Oracast to take over that, it will be a very long and slow process. And I think, you know, for the next 10 years at least, probably the two systems will interact at the same time. Of course, the ideal would be to have everything in the hearing aid, wouldn't it? So then it's like your phone. So you can use a telecoil, you can use this, you can use that all at the same time. But we shall see how that goes. Wi-Fi and infrared. Yeah, Wi-Fi is used for conferences, meeting rooms with these automatic cameras on, and all those kind of things. The only problem with Wi-Fi is it's a very restricted bandwidth, if you like. So once you start piling a load of people on there, so you get 300 or 400 or people all using the same system, it tends to get a bit creaky. The other side with Wi-Fi, because of the way it's made, it's got quite a lot of data to process, so it can result in latencies. Now, if you're just listening to music or a speech, it doesn't matter. But if you at the same time someone's speaking on a film or a documentary or music or something like that, and then that person's lips are out of sync with the actual information hearing, it obviously can be very annoying. Infrared is not so commonly used now. I dare say there's still a few installations out there, and obviously it's just a line of sight thing, very easy to install. And again, you could have incredibly high data rates with infrared, so you know, very good quality if set up properly. But again, if you're listening and connecting to other bits and bobs, you can create latencies. And also in buildings with windows, you can get interferences with those kind of things. So it's a little unstable, to be fair, but it probably still has its place in many areas, sorry, should I say, for some time to come. So what is the perfect system? Well, again, you know, back to the phone analogy, there isn't really one that exists. It's really what has been optimized for the thing that you want it to achieve. You know, it's not, as we mentioned before, and certainly live speech is a huge one. You know, one of the reasons latency is bad, particularly over about 30 milliseconds, particularly with hearing loss, is it can be quite irritating hearing your own voice at quite a high level. You know, if you're out there using a wireless device or Wi-Fi or whatever to talk to someone, and the latency of that signal is above 30 milliseconds, it just makes your life, you know, impossible to actually understand that information. Obviously, if you're listening to music, the acoustics don't really matter. So things like the ATD profile is perfectly fixed. That's fine. If you are working in more challenging acoustics, you will need some form of more traditional, shall we say, wireless technology to help cope with those acoustic environments. Because at the end of the day, it's all about the signal to noise ratio. So no matter what technology you're using, whether it's Oracast, Boracast, Zigbee, whatever, you know, it's still a fixed system. So it's all about the signal to noise ratio difference between your hearing aids and the signal coming from that transmitter in the first place. And I say, mentioning a phone call, it doesn't matter. You know, use it for music. Certainly nowadays, modern hearing aids can classify music in a slightly better way than they used to before. So that's great if you know if you're into that. But there is only a limit to that you can actually go to. So it's really just depends on what you want to do in those challenging or more of those different types of situations, should we say. To the next one. Power consumption is huge. It's quite staggering how a modern hearing aid can power all these different types of scenarios. And you will see that more hearing aid manufacturers now are going to rechargeable batteries. And obviously the benefit of that is you reducing electrical waste and all those kind of things. but a rechargeable battery can deliver more power or more current per unit time than, say, a normal pin back small battery, a normal hearing aid battery that they use. And that's just due to the chemical reaction. It's the sort of more chemically based ones, well, all chemically based, but the more sort of pin batteries or coin batteries, they just can't physically deliver those higher current levels that are needed to run all these amazing technologies that we've got in there. So the other side of the coin is, as well, is that in most cases, manufacturers buy chips off the shelf. Now, it's quite common, it's kind of weird, but you could have the same processor in your laptop as you have in a fridge or if you have in a car. They're more just generic things that manufacturers program to do all the things that they want to be able to do. And the reality is they can't always do that. So there's always a compromise between the time, power consumption, and on all those kind of things as well. And this is really one of the issues with Bluetooth Classic. It's still very power hungry, but it has to be said, in terms of compatibility and usage, it's the most compatible Bluetooth technology currently existing. And certainly I think that will probably be around for at least the next 10 to 15 years in one way, shape or form. Okay. So most important factors, I believe, are the consistency of function, which we started about before, and that's really just a posh way of saying when you're using the technology, it needs to be consistently work in the way that you want to do it, or people just get annoyed with it, etc. Standardization is a huge part of this. As you said, if everybody used the same standards, certainly all those other things would be dramatically improved in many different ways. And I think it's very important to make it as simple as used as possible. Any technology that is awkward to use, you get bored with it very quickly, don't you? And it just doesn't work in those kind of ways. The future. I say at the moment, it's likely that the number of formats will increase, certainly. Currently, I think, on average, you can have about up to 6 different wireless technologies within a hearing aid. And it's more than likely that bright people will invent many more and some time to come. Even telecoil, I think, is going to be around for at least 10 years, and that could be pessimistic. And this is due to simplicity and literally the volume of equipment used. And, the other thing to look at as well is not just the cool stuff that we're going to come out, or all manufacturers are going to come out with in the next year or so. You've got to think some people could be using hearing aids that are maybe 10 years old. Some people, you go to a venue or a theatre, they've got a T-coil system in, or they're going to rip that out and put another system in. So all these things take time. So it's not necessarily just what works with what you've got now. You've got to think about, does it work with what we had 10 years ago, with what 15 years ago, maybe even 20 years ago, in some scenarios. So certainly the number of Bluetooth formats will increase. I think for the meantime, Classic is the most mature technology, and because it's the most mature, it's probably the most reliable, and it certainly is the most compatible. I think the exciting bit is the low energy forms that are coming up. I think this will offer new opportunities, but it will take some time to increase standardization and function and penetration in the market. Now, what I mean by that is quite interesting. I mean, Auracast is fantastic. I certainly think in the hearing aid industries, it will generally change things, and we all work together on that. I mean, the Phonak R&D, Oticon R&D, etc., etc., etc. But the slight issue is it's almost come out a little bit too early in many ways, because the actual Auracast term is not standard. It's basically a marketing term currently. They are working on a standard, and they're working on lots of interoperability, etc., etc. But as with all these things, and again, it's not just a hearing aid world, Auracast is used outside that in many different formats. People will naturally, or companies will naturally make products that work better with their own devices. A classic example is a sort of landline phone or something like that. And because there isn't the standard, guess what? Everyone kind of creates their own standard, loosely around the generic concepts of the Oracast chip. And this can create a lot of issues and inoperability and those kind of things. Obviously, it was the same case with Bluetooth Classic when that came out, 20 odd years ago. But obviously, over time, as I mentioned before, these technologies kind of converge, and you will see a lot better interoperability between different manufacturers, and that's how it should be. The whole concept of Bluetooth is you shouldn't have to have Phonak hearing aids or GN or Oticon or whatever. You should be able to just go to the theatre, turn it on, and off you go. But it's not quite there yet. But I'm sure in the next few years, as the adoption rises, the need for it will, and all these kind of things will be sort of ironed out in the coming years very shortly. So inclusion, I think all technologies tend to converge, as we mentioned before, phone use and those kind of things, and it's no doubt different really for hearing aids in themselves. And in terms of access to the world, coming back to what we were talking about earlier, the amount of times you use these technologies on your phones or across a table or whatever, those kind of things, why shouldn't you be able to do that with a hearing aid? Use the Wi-Fi, connect on Teams calls, do all these other weird and wonderful things. And it's really wireless technologies that have done that for us. But, as we mentioned earlier, it's not necessarily about all the cool stuff or the cool names. It's really what you want to achieve. And, any technology has to be really, one, standardized. I think, we all do that in all the different companies, and that will improve over time. And it also has to be easy to use, because at the end of the day, that's in our interest as a manufacturer to encourage standardization, isn't it? If someone gets some fantastic hearing aids that you've fitted for them and they go away, they're just an absolute pain from day one getting them to work with anything, you'll just end up turning off those features. So it's in everybody's interest to get those, so they go away and tell their friends and colleagues or whatever, we've got these great hearing aids and now I can do this, or listen to my phone, or use Siri or Google or whatever you want to do. I think you will see a lot more of that to come in the future. I think health monitoring as well is a really interesting one. We've had a few of those sort of kind of Fitbit things in hearing aids, and there's medical ones. I think there's a manufacturer now that's also got using sort of heart rate monitoring and those kind of things. And I think it's quite staggering, but I always say, one day you'll hear the doorbell ring and there'll be an ambulance waiting outside, and go, what on earth are you doing here? You've got the wrong house. And they'll say, well, Mr. Murphy, you're going to have a heart attack. Because, those kind of things you can do. You can do a lot more with hearing aids monitoring within the ear and all those kind of things for prevention, those kind of things as well. If anyone's had elderly parents, so there's going to be a lot of these technologies, I think, probably will just become standard in the next 5 or 10 years. But the actual ones, obviously, we'll have to wait and see on that. So hopefully you found that interesting. Is there kind of any questions on any of the things we've discussed so far? Hopefully everybody actually heard that lecture.
Yeah, I'm sure they did. Is there any question? I don't see any. Maybe you can answer one for me, Tony. When customers ask me if they could, they say, I've got a smart TV. Could I Bluetooth to my TV? And obviously I always say, oh no, you need an interface, the television device. I don't understand why, but obviously that is the case. Can you?
Yeah,
why can you not?
I mean, it can obviously be a number of different things, and that is the classic thing, isn't it? I've got a smart TV, so it should just work with anything in the world and from Mars as well. So it's all in the name, and in fairness, that's a classic example of, say, the TV manufacturer. They don't make hearing aids. When they design a TV, it comes back to Oracast again, because I mentioned this now, I forgot to mention it before. A lot of TV manufacturers now are beginning to incorporate Oracast into their televisions. And Oracast comes in 3 forms, different audio bandwidths, 16, 24, and 48 kilohertz. Now, if you're a TV manufacturer, when you look at how the sound and what you want to do, and you discover this fantastic new thing called Oracast, you can beam straight into a set of our fantastic headphones and listen to a nice signal. What are you going to do? You're going to broadcast at 48 kilohertz. Yeah. Now the problem is, I know Oticon can accept 48 kilohertz. I'm not telling you what ours can do, but that won't necessarily give a better quality of signal to that person, because guess what? Hearing aid can't stick 48 kilohertz signal, Oracast signal, out through its receivers. But for the person using that, it comes back to what we were talking about before, that the person using those hearing aids is not going to sit down and go trawl through the data sheet for your latest Samsung TV or whatever. Oh, I wonder if my hearing aids have got 48 kilohertz compatibility. And the answer is they don't know. They don't really care. If that hearing aid can accept that signal without having to do anything else, then that's fine. And the classic example would be the smart TV. Maybe they've used a different form of Bluetooth. Maybe they used their own Bluetooth that isn't necessarily a standard, but the engineers that developed it didn't do it for bad reasons. They did it to give the best quality that they possibly could for their own products. So it's not always, shall we say, the same standard, if that kind of makes sense. And that can create issues along the way.
Okay, thanks for that, Tony. Is there something in the, is there any questions in the chat, or people just thanking us? Okay. Right, wonderful. Well, thank you. Thank you very much. If there's no other questions, then we'll end it here. So I hope today's session's given some practical insight. Yeah. I've certainly learned a few things today. So on behalf of BSHAA, thank you for attending, and we look forward to seeing you at any future CPD events.